here dealing with extrapolation, which is quite exciting because I did not expect the increments to predict such a pattern, because this prediction here is a lot better than what we would predict out at 90. So if you look at this, we go past 90 or go out to 90, we're expecting the displacement in the x direction to be 0. And it's actually happening with this this interpolated kind of this assumption that we're making here. And that's really, really cool. So we want to generate an equation for this as well. And so we're going to do that in just 1 second. I want to make a point. The point is that this equation works well between 0 and maybe 25. We didn't even go out to 25. You know, we haven't even tested that, but it works well for this range here. Okay, it just doesn't work well outside of this. So it's always instructive to ask, well, what are the parameters, you know, in which we're working? So let's go to the next page, and you'll still see that we have 20 here. Okay, it's still appearing to work well. And at 20, we are at, it looks like we're around 0.9, and at 10, we're still at about 6.5. So if I select on 10 right here, let me see if I can select on 10. 10 degrees, we still have about 0.64. The number has changed a little bit, but let's add a trend line. In this particular case, it's trying to plot a linear trend line. We don't want that. We want a polynomial. And in this particular case, you guys can see that this polynomial is fitting with this trend line pretty good. So right now it's a second degree polynomial. Okay. And I'm just going to move this up, and I want to make this big. So in this particular case, I won't make it as big as I did last time. So we have ourselves a second degree polynomial, okay, which works fine. Look at R, the R value. It's 0.99528. I don't think I explained to you guys that the R value is really speaking to how well this line is fitting to these values, okay? It's the closer it is to 1, the better, okay? But let's do that again. Let's see if we can get a better value, because Excel allows us to do this. And I don't see why you can't. So I'm going to add another trend line. And I want this to be a polynomial, but I want it to go to degree 4. So we had a second degree. And now degree 4, we display this on the chart here. I'm just going to pull this down. And let's increase this to 24 or maybe 20. Okay. So now we have this equation, and it's describing what's happening. And if you look at it, it's actually hitting those points very well. Let me change the color, if I can, of that particular line. Can I do that? I'm sure that I can. I'm not quite sure if, let's see if I can change it. Nope, that's not what I'm trying to do. I am trying to change the color of this line. So here it is. I'm gonna go here. I'll just make it red. So the red line is this bottom equation. And look, it's hitting almost every point as it goes down. The blue line is not doing the same thing. It's making a pretty good prediction, okay? But we're saying that, oh, well, with this, the first one is a quadratic equation, and the second one is a quartic equation. And so we can develop all kinds of equations, and you know, we can make all kinds of predictions. And this is a pretty good prediction fitting this data or fitting this assumption. But will this actually fit with what we are? What actually happens? And so that's what's going to come in the next video series. So now that we're finished with this, you just go ahead and save it. If it's on your desktop, it'll save directly back to your Dropbox. If not, you're going to probably have to upload it. In other words, if you pulled it down through a web browser or something like that, or emailed it to yourself, then you're going to have to upload it to your Dropbox into the appropriate folder. So once you do that, make sure you go ahead and save that. You go ahead and share that with me on STEM. Okay. So I wish that I could, I'm going to take some snapshots of this, and I'll probably put this in the lecture.